Welcome to this explainer. Okay, picture this. You just spent 3 absolutely grueling days building a brand new software feature. You run it on your machine, it compiles perfectly, the output is exactly what you want, and you've rigorously tested it. So you're feeling fantastic, right? Confidently, you push that code to production. But then, a few hours later, users start reporting issues. The application slows to an absolute crawl, and worse, a massive security vulnerability is discovered. It turns out a tiny mistake in just one single function has triggered this massive domino effect of unexpected problems across your entire system.
And that brings us to the million-dollar question, doesn't it? If the program ran correctly on your machine, and if the output was totally fine, what actually went wrong? Well, as students and beginners, it is incredibly easy to fall into this illusion that compiling equals finished. We're kind of trained to think that once the computer accepts our code without throwing some massive red error message at us, boom, we've crossed the finish line. But we really need to break that illusion today. To do that, we have to understand a fundamental truth of professional software development. Writing code, that is literally only half the process. The computer executing your commands is just the bare minimum requirement. So to figure out what the other half of the process is, we have to completely rethink who we're actually writing code for.
And this highlights a massive mindset shift between a beginner and a pro. Beginners usually write code strictly for the machine. The only requirement? It just needs to work. But professional developers, they understand that software is actually written for humans first and computers second. Your teammates need code that is understandable and maintainable. Your company needs code that is scalable. And honestly, your future self needs code that is readable 6 months from now. You really don't want to look back at your own work and wonder, who on earth wrote this tangled mess? The computer doesn't care if your variables are named with single letters or if your logic is ridiculously convoluted. But the human beings who have to work with that code, they absolutely do. So how do we bridge this gap? Well, it helps to remember that even the very best authors need editors. Think about a best-selling novelist. They don't just hammer out a first draft and immediately publish it to millions of readers. That would be completely chaotic. No, they send it to an editor, a fresh second pair of eyes to catch plot holes, fix grammar, and just smooth out the narrative flow. It's the exact same thing in software engineering. Literally everyone, from a day-one programming student to a senior engineer with 20 years of experience, needs an editor before they publish their work. So let's nail down exactly what this editing process is. Code review is the process of examining code written by another developer before it becomes part of the main project. And notice that absolutely crucial word there, before. Instead of just immediately merging your shiny new feature into the live application, another developer steps in to look over your changes and give you feedback. I really want to emphasize here that this is a collaborative checkpoint. It is not some personal test or an exam grading your worth as a programmer. Not at all. It's simply a safety net, a shared quality control measure to make sure the whole team is shipping the best possible product.
And let's be real, the financial stakes of skipping this editing step are completely massive. A bug caught early in development, say during a code review, might take, 5 minutes to fix? You tweak a line of code and you're done. But if that exact same bug makes it out into production, the cost suddenly skyrockets to hours, days, or seriously even millions of dollars. Just imagine you're building a banking app. You accidentally write a condition the wrong way, and the code transfers money even when a transaction should have been rejected. The code compiles, it runs, but it is a logical disaster. A quick peer review catches that logical error immediately, preventing a potentially catastrophic financial meltdown.
But it goes way beyond just logical bugs. Reviewers actually act as a shield against invisible threats that automated tests will just completely miss. As a student, it is so incredibly easy to accidentally write a vulnerability. Take SQL injection, for example. You might directly insert user input into a database query. It works perfectly when you test it locally. But a reviewer, they're going to spot that and immediately flag it as a huge security hole, where an attacker could literally wipe your entire database. They'll also catch things like insecure authentication, weak encryption, or that classic beginner mistake, accidentally leaving your secret API keys exposed right there in the code. A single review catching just one of these threats is a real game changer.
Okay, so aside from security and, catastrophic system failures, what are reviewers actually checking on a day-to-day basis? Well, they're looking for unclear variable names, because naming a variable X or data2 helps literally no one figure out what's going on. They look for duplicate logic that could be easily simplified. They're checking for missing error handling or overly complex functions that are just trying to do way too much at once. And formatting. They check for inconsistent formatting. Reviewers enforce these standards so that when another developer opens that file a year down the road, the code is consistent, readable, and predictable.
So the main point is that reviews catch mistakes, right? Well,
Yes, but there's actually a massive hidden benefit here: knowledge sharing. This reduces dependency on individual developers. A lot of people think reviews only exist to find bugs, but in reality, it's the ultimate learning tool. Junior developers learn best practices just by having senior developers review their code, and at the exact same time, the whole team gets familiar with different parts of the codebase. The knowledge spreads. Because if only one person understands a critical system and they go on vacation or leave the company entirely, the team is in deep trouble. Code review ensures the whole team levels up their skills together.
Now that we know why this is absolutely crucial, how do we actually do it well? Because great developers don't just write good code, they write code that is easy to review. So here are some actionable steps for you. First up, create small pull requests. A pull request is just the formal request you make to your team to review and merge your code. Massive 2,000-line code dumps? No way. That slows everyone down and makes a good review impossible. Keep them small. Second, write clear descriptions explaining what the code actually does. Third, keep your changes focused on a single objective. Don't try to fix a bug and refactor the entire database in the same review. And fourth, add documentation. Doing these things makes your code an absolute joy to review, keeping your whole team moving fast.
Now, I know what some of you are probably thinking. Handing your code over to be judged sounds terrifying, right? It's perfectly natural to fear criticism, but we really need to reframe how we view feedback here. Toxic feedback attacks the person. You wrote this incorrectly. But a healthy review culture, it uses constructive feedback. This section might be improved by using a different approach. You have to remember, a review is an evaluation of the code, not an evaluation of you as a person. Even the most senior engineers get feedback every single day. Once you realize that constructive criticism is actually the ultimate technical growth hack, you'll stop being defensive and start seeing every review as a massive learning opportunity.
And hey, we really can't talk about the future of coding without bringing up artificial intelligence. You might be sitting there wondering, if AI can just write my code for me, do we really still need code reviews? The answer is a resounding yes. AI-generated code absolutely still requires human review. Sure, AI tools can write code incredibly fast, but that generated code isn't always optimal. It can very easily introduce those invisible security vulnerabilities we were just talking about. It might ignore your specific project standards or hide some messy inefficiencies. So even as we embrace the future, human code review remains an essential quality checkpoint to make sure what the AI built is actually safe. Which brings us to our final takeaway. If you want to become a future-ready developer, code review isn't just some optional extra step. It is the absolute core of professional software development. So the next time you finish writing a block of code, I want you to stop asking yourself that beginner question, does it work? Instead, try adopting a new personal mantra. Would another developer understand, trust, and confidently maintain this code? Great software is always a result of collaboration, discussion, and continuous refinement. So embrace the review process, soak up that feedback, and start writing code for humans. Keep coding.
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to FuturE BreaK CodeR, because many exciting coding and futuristic tech